Okay, so the first thing I'm going to want to do is get this problem into the standard form. And so to do that, all we got to do is just divide by this coefficient right here, that a naught or a1, a sub 1. So what you end up with is you end up with dy over dx minus 2 over x equals, is this the correct problem? Yes, it's the correct problem. You do that, and then you end up with just x, and then the next step is, so now that this is in the correct format, like this, we move on to step 2, where, well, first we're going to identify that this right here, including the negative sign, is our p of x, which helps us for when we calculate mu of x. So calculate mu of x, which is just equal to e raised to the p of x dx, which in this case is e integral of, this is just the same as writing it out like this, dx, and then we get e to the negative 2 natural log of, or we get, 2 to the ln of the natural log, and no c, there's not going to be a c. Okay, and then this part kind of tricked me up a little bit when I first saw it, but then I realized, because if there's an e raised to the ln of x, I was a little confused by that, but then I learned through the video that there is a log rule, and so it's just mu of x equals e to the ln of x squared, which is pretty useful because e to the ln will just then cancel out. You get mu of x equals x to the negative 2 power. So calculate that, and then what you got to do next is just multiply both sides of d by mu x. So just take this part and multiply it by up here. And so doing so, you get x to the negative 2 power dy over dx, right? And then you, I messed this up actually. It's going to be a plus, right? Because, it has to be in that plus format, and that's why the professor was making sure to make a note of that. So yeah, keep the negative in here, make that a plus. Now we're good, which explains why this is a negative over here. All right, so then you go to plus negative 2 negative 2 over x times x to the negative 2 power, right? And then we have our y equals x times x to the negative 2. So just doing some algebra right here, get x to the negative 2 dy dx plus this right here then is the same as negative 2x to the negative 3 y, and then this right here is x to the negative 1. And then what's nice about this is that if you using the chain rule, if you just take the derivative of this, you get negative 2x to the negative 3. So I'll write that over here. dx of this gives you this, which we see over here, which is the whole point of how this works. And so what we get is that there is a function and its derivative. So this is the function f. This is f prime of that function, right? That's the derivative of that. This is g prime of this y, which is g. So you got that. And then the final step is just to integrate this whole thing and solve for y. So let me do that right now. Integrate. And so the way that you do that is you're basically just going to the way you do it is just d over dx x minus 2 y dx, right? Because we're only going to really care about integrating, this is obviously going to cancel. We don't need to integrate, so what you want to do is just do that part right there equals the integral of x like such, and then you're just left with x minus 2y equals the integral of 1 over x, which is the same as just ln of x plus c. And then this is just like such. And then so just to solve for y, just divide it by that. Get y equals ln of x plus c over x to the negative 2. And yeah, this is the final answer. And if we needed to, if it was an IVP, we could just plug in the x and y and solve for c and then continue on. But for now, this is it. Some trouble that I had with this problem, I had seen an example basically done in class. It was tricky. I just needed to stick with it a couple times. I think some of the algebra was like a little bit annoying, but once I was able to kind of verify that my mu of x was indeed, its derivative was indeed already present in the, once I multiplied both sides, once I saw that it actually worked out, I was convinced that I was doing the right process. Also, I wouldn't have known, in just all honesty, I probably wouldn't have remembered off the top of my head the integral of this other than negative 2 ln of x. I wouldn't have been able to simplify. Like, I don't think mentally I would have thought to simplify that further into this. So I'm glad that the professor reminded us of that rule. Um, and then, yeah, just taking the integral of both sides. And basically, the fourth step is once like you're kind of in the clear, but getting everything set up and making sure that um, I kept it in the standard form. So making sure that it's a plus as opposed to um, a negative or something like that. So yeah.